Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium. In this session, we are going to solve some PYQ of JEE main. Let's start the session. Okay. Here is the question which is asked in 2020 JEE main. 2020 JEE main. So let us see that question. For the following assertion and reason, the correct option is, okay, what is that assertion given? Assertion, the pH of water increases with the increase in temperature. Increasing temperature, on increasing temperature, he is saying that pH of water increases. Is it correct or wrong? So let us see. We know that Kw is ionic product of water, which is equal to H plus ion concentration into OH minus ion concentration. Okay. At what is that? At 25 degrees centigrade. At 25 degrees centigrade, which is equal to 298 Kelvin. We know that Kw is equal to 10 power minus 14 mole square per liter square, in which H plus ion concentration, which is equal to OH minus ion concentration, which is equal to 10 power minus 7 molar. 10 power minus 7 molar. On increasing temperature, see, Kw is dependent only on temperature. How is it dependent only on temperature? On increasing temperature, Kw increases. What happens? Kw increases. Okay. That means on increasing temperature, Kw will be greater than 10 power minus 14. 10 power minus 14. Let us see that at 25, first at 25 degrees centigrade, we know that H plus ion concentration is equal to 10 power minus 7 molar or normal. And pH, how to calculate pH? pH of water. This is what? Water. pH is equal to minus log H plus ion concentration, which is equal to minus log 10 power minus 7. That is equal to minus of minus 7 log 10. That is equal to plus 7. So pH of water is 7. How much? pH of water is 7. Now on increasing temperature, let temperature increased to something like 80 degrees centigrade. When temperature increases, Kw increases. Let Kw is increased to 10 power minus 12 molar square. Okay. And we know that Kw is equal to H plus ion concentration into OH minus ion concentration. Okay. And one water molecule on dissociation gives you one H plus and one OH minus. Okay. One water molecule on dissociation gives you one H plus and one OH minus. That means here 10 power minus 12 is equal to 10 power minus 6 into 10 power minus 6. That means now H plus ion concentration is equal to how much? 10 power minus 6 molar. Then calculate pH. pH is equal to minus log 10 power minus 6. That is equal to minus of minus 6 log 10 base 10 that is equal to plus 6. What happened on increasing temperature? On increasing temperature, pH is decreased. On increasing temperature, pH is decreased. So is that statement right or wrong? It is a wrong statement. It is what? A wrong statement. Next reason, let us see reason. The dissociation of water into H plus and OH minus is an exothermic process. Exothermic process. We know that H2O dissociates into H plus and OH minus. Plus and OH minus. See here H2O oxygen, right? Hydrogen. Here is hydrogen. If it want to dissociate into H plus and OH minus, some energy is to be absorbed. This bond is to be broken. What happens? This bond has to be broken. If this bond has to be broken, some energy is absorbed. Energy is what? Energy is absorbed. If energy is absorbed, what will be the nature of the reaction? The nature of the reaction is what type of reaction is that? Endothermic reaction. Endothermic reaction. So if water molecule is to be converted into H plus and OH minus, you have to supply some energy to break this bond. So when some energy is taken to break the bond, some energy is being absorbed, then that type of reaction is called as a endothermic reaction. So what is regarding this reason? The reason is here it is given exothermic, so it is also wrong. So both statements, that is both assertion and reason, are wrong. So both assertion and reason are false. So that is the answer. Okay, so let us see next question. Here is the next question. So 200 ml of 0.01 m HCl is mixed with 400 ml of 0.01 m H2SO4. The pH of the mixture is. What is given here? Let us see. Both are acids. What is that? Both are acids. So here is what given HCl. Here is what given H2SO4. H2SO4. Okay. Now, how much volume is given? Volume is equal to 200. Right? Concentration, let us convert it into normality. Normality is equal to 0.01 normal. This molarity is equal to normality for HCl. Okay, we know a formula. What is that formula? To convert the normality into molarity into normality. Normality is equal to molarity into N factor. Molarity into what? N factor. So what is N factor for HCl? For HCl, N factor is equal to 1. So for HCl, normality is equal to molarity. And another one, H2SO4 is given. For H2SO4, N factor is equal to 2. So normality is equal to molarity into 2. So what is this? This is V1 N1 we are calling, because let us take this solution as 1. What is this solution? This solution as 1 solution. This is 2. So volume 2 is given as 400 ml and normality is equal to molarity into N factor. That is equal to molarity, how much given? 0.01. 0.01 into N factor, how much? 2. And that is equal to 0.02 normal. N2. So now what did he do? He mixed these two solutions. This solution is mixed and this solution he has added and mixed. What is this? Mixed. Such type of question we have seen while describing about the concepts. Here both are acids, so there will be no reaction between them, just they get added up. So let the number of equivalents of first solution be how many? N equivalents 1. Let the number of equivalents of second solution be N equivalents 2. Number of equivalents. Now, number of equivalents of this is mixture. We have mixed these two. So, number of equivalents, we have another formula. What is the number of equivalents formula? Number of equivalents is equal to weight by equivalent weight. So, when you are adding these two, when there is no reaction, there will be no change in the number of equivalents. These number of equivalents just get added up. Number of equivalents just get added up. Another formula to calculate number of equivalents, normality is equal to number of equivalents by volume in liters. Okay, so number of equivalents is equal to normality into volume expressed in liters. Or otherwise milli equivalents. If you take milli equivalents, what is that? Milli equivalents is equal to normality into volume when expressed in milliliters, then we get milli equivalents. Okay. Now, when you are adding these two, what happens to the number of equivalents of the mixture? So, number of equivalents of the mixture, there is no reaction and these two are acids, they get just added up. Number of equivalents 1 plus number of equivalents 2. And number of equivalents, we have formula normality into volume. Both solutions are given in milliliters, so no issue with volume. So I can write here normality of mixture into volume. Okay, so this will be equal to normality of 1 into volume 1, volume of mixture here, plus normality 2 into volume 2. So normality of the mixture will be equal to N1 V1 plus N2 V2 by volume of the mixture, means after adding both the volumes get added up. Here is 200 ml, here is 400 ml. When you mix them, it becomes 600 ml, right? Then that will be equal to V1 plus V2. Okay. So normality of the mix is equal to N1 is how much? 200 ml into, normality, volume, normality is 0.01 N plus 400 ml into normality 0.02 N by total volume is equal to, okay, 200 plus 400 ml, right? Then this is equal to 200 into 0.2 plus 4 to 8. What do you get? Normality into ml by 200 plus 400 is equal to 600 ml. So as both are ml, we can cancel them. Then normality of the mixture, so normality of the mix is equal to 10 by 60, 600. That is equal to 1 by 60. 1 by 60. Right? So now we know that for a strong acid, both are added. What are added? Acids are added. When both acids are added, then the resulting solution will also be acid. So for a strong acid, normality N means normality of acid. Acid is equal to its H plus ion concentration. Its H plus ion concentration. Okay. Then here normality is given as 1 by 60. Then H plus ion concentration will be equal to 1 by 60 normal. That is equal to 100 into 10 power minus 2 by 60. Cancel. So what do you get? 5 by 3. 5 by 3 into 10 power minus 2. So H plus ion concentration is equal to 5 by 3 into 10 power minus 2. Then let us calculate pH for this. We know that pH is equal to minus log H plus ion concentration. That is equal to minus log 5 by 3 into 10 power minus 2. Okay. So minus of, okay. Then what do you get? Log A plus B is equal to log A. Log A into B is equal to log A plus log B. So minus, so log 5 minus log 3 minus plus minus 2 log 10 base 10 equal to minus log 5 is equal to 0.7 minus log 3 is equal to 0.4771. So otherwise you can write 0.477148 we can write. Okay. Plus minus 2. Then that is equal to, so minus of right 0.7 minus 2.48. So that is equal to, then what do you get? 2.48, 2.48, 0.708, 14.7, 1.78. So what do you get? Minus of minus 1.78, which is equal to plus 1.7. Understood? So how much did we get? pH is equal to 1.78. So where is that answer? 2. 1.78. Okay. Next, let us see another question. So recently, these JEE mains questions are not easy. They are given not so easy, so much easy. First of all, we need to understand the question, especially in physical chemistry, there will be a lot of mathematical operation involved. So, more the number of questions you practice, more you will be able to solve the questions of JEE main. Okay. So, let us see question number 5. When the hydrogen ion concentration changes by a factor of 1000, then the value of pH of the solution. Okay. Let us solve it by taking an example. Let us solve it by taking an example. Let us take for example, there is a solution 1. Solution 1. Okay. So pH is equal to, we know that minus log H plus ion concentration. And H plus ion concentration is equal to 10 power minus pH. Okay. So now pH of the solution, let me take it as 4. Let me take it as 4. then H plus ion concentration will be equal to how much? 10 power minus 4 molar or normal. Right? Now what he is saying, now we are changing the H plus ion concentration. So H plus ion concentration changes by a factor of 1000. That means 1000 times it increases. 1000 times it increases. Okay. Now H plus ion concentration is changed to 1000 into 10 power minus 4. It is changed by a factor of 1000 times. 1000 times to that of 10 power minus 4. Then what happens? H plus ion concentration is equal to 10 power, what do you write? 10 power minus 10 power 3 into 10 power minus 4 molar. That is equal to 10 power minus 1 molar H plus ion concentration. Then what will be pH? Now write pH. pH is equal to minus log 10 power minus 1. That is equal to pH is equal to 1. So what observation did we find? Observation found is that when H plus ion concentration is changed by 1000 times, pH is decreased by how many units? This is 4, this is 1. So pH is decreased by how many units? 3 units, right? pH is decreased by 3 units. So answer will be first option. Okay, understood. Next, let us see the other question. See, pH of water is 7 at 25. If water is heated to 80 degrees centigrade, its pH will, asked in 2025, very recent examination. Now only we have seen H plus ion concentration. So we have studied that on increasing temperature, Kw increases. If Kw increases, then H plus ion concentration increases. Let us take example. For example, we know that H plus ion concentration is 10 power minus 7 molar at 25 degrees centigrade. Let the H plus ion concentration will be 10 power minus 6 molar at 80 degrees centigrade, for example. So then what is pH? So pH is equal to minus log H plus ion concentration minus log 10 power minus 7, that is equal to plus 7 pH. At what temperature? 25 degrees centigrade. Let us see at 80 degrees centigrade. 80 degrees centigrade H plus ion concentration, we have seen that it is 10 power minus 6 molar. Then pH will be equal to minus log 10 power minus 6, that is equal to plus 6. So what has happened to pH? From here to here, what did you find? We have found that the pH of the solution has been decreased. So on increasing temperature, Kw increases. If Kw increases, H plus ion concentration increases. If H plus ion concentration increases, pH decreases. So the answer will be second option. Simple question, but we should know the concepts regarding this. Okay. Next question. An aqueous solution of HCl is diluted by adding equal volume of water. Ignoring dissociation of water, what will be the pH of HCl solution? Okay. pH of a HCl solution. Let us solve. Here, an aqueous solution with pH is equal to 1. So pH is equal to 1 given, right? then H plus ion concentration is equal to 10 power minus pH, that is equal to 10 power minus 1 molar, that is equal to 10 power minus 1 moles present in 1 liter. Let us take in this way, H plus ion concentration. So it is diluted by equal volume of water. Now what is done? H plus ion concentration is made 10 power minus 1 moles by initial initial volume is let us take initial volume is V initial is 1 liter. Now what did you do? Equal volume. That means 1 more liter of water is added. So what will be V final? 1 plus 1, 2 liters. So I am taking here it as 2 liters. Why I am taking here it is asked. It is diluted by adding equal volume of water. How much initially volume is HCl volume solution, HCl solution volume, the same volume it is diluted with. Okay, so then what do you get? H plus ion concentration is equal to 10 power minus, so this can be written as 10 into 10 power minus 2 by 2. Then what do you get? So 5 into 10 power minus 2. So H plus ion concentration will be 5 into 10 power minus 2. So what is asked? pH is asked. So then pH will be equal to, so pH is equal to, we know, minus log H plus ion concentration, which is equal to minus log H plus is 5 into 10 power minus 2, that is equal to minus log 5 plus log 10 power minus 2, that is equal to log 5 is equal to 0.7, okay, plus minus 2 log 10 base 10, that is equal to minus 0.7 minus 2, that is equal to minus of 1.3, that is equal to plus 1. So pH is becoming 1.3. So it is increased. Actually its pH, initial pH is how much? Initial pH is only 1.0. Now it has become 1.3. So is it increased or decreased? It is increased. So the pH is increased to 1.3. pH is increased to 1.3. Understood? Okay. Next, let us see the next question. Dissociation of weak acid. Here it is asked about the dissociation of a weak acid. So weak acid HA has degree of dissociation X. Which option gives the correct expression for pH minus pKa? pH minus pKa. So already it is given that degree of dissociation is degree of dissociation of the acid is equal to X. Is equal to X. Let us see. HA is dissociating. HA dissociates to form H plus and A minus. Okay. Then let at time 0, let C be the degree of dissociation. Let C be the concentration of HA, and there is no H plus and there is no A minus. Okay. At equilibrium, let C alpha be degree of dissociation of HA, and we know that when 1 mole of HA dissociates, 1 H plus and 1 A minus is formed. So how much H plus will be formed? C alpha. How much A minus will be formed? C alpha. What amount of HA remains? C minus C alpha. And what can you write Ka? So Ka dissociation constant can be written as dissociation constant of acid. Dissociation constant of acid. Ka can be written as H plus ion concentration into A minus concentration by Ha concentration. Okay. Then what you can write now? So Ka is equal to H plus ion concentration into A minus. A minus is at equilibrium. At equilibrium, you are finding A minus is C alpha. Ha is C minus C alpha. So what you can write C alpha by C minus C alpha. So Ka is equal to, so instead of alpha, what he has asked us to take, he asked us to take what x. What he has asked us to take x. So what you can write x, x, x. Here also x, x. So H plus ion concentration will be equal to H plus ion concentration into Cx by C into 1 minus x. Cc gets cancelled. Then Ka is equal to H plus ion concentration into x by 1 minus x. Okay. Then what you can write? Take logarithm on both sides. So now what I am writing? Now let us write Ka is equal to H plus ion concentration into x by 1 minus x I am mentioning. Minus log Ka is equal to minus log H plus ion concentration into x by 1 minus x, right? Then I can write this can be written as pKa. This is equal to minus log H plus ion concentration. Okay. Minus log H plus ion concentration plus log, what you can write x by 1 minus x. Okay. Log A into B is equal to log A plus log B, no? So log H plus ion concentration into x by 1 minus x. And this. So pKa is equal to, what you write? Minus log H plus ion concentration minus of log x by 1 minus x. Okay. So pKa is equal to minus log H plus ion concentration can be written as pH minus log x by 1 minus x. Okay. I'm writing here. Now, so pKa minus pH is equal to minus log x by 1 minus x. Okay. Multiply minus on both sides. Multiply minus on both sides. Then what do you get? Minus of pKa minus pH is equal to minus of minus log x by 1 minus x. Okay. So then I can write it as pH minus pKa is equal to plus log x by 1 minus x. Okay. So what is the question asked? Let us see once again question. The question asked is pH minus pKa. What is that? pH minus pKa. So here we have derived it, pH minus pKa is equal to log x by 1 minus x. Do we have that? Log x by 1 minus x. Yes, third option. Log x by 1 minus x. Understood? So that's the answer. Let us see the next question. So coming to the next question. So first of all, Let us see two solutions A and B. Each is 100 liters was made by dissolving 4 grams of NaOH and 9.8 grams of H2SO4 in water. Okay, respectively. The pH of the resultant solution obtained from mixing 40 liter of solution A and 10 liter of solution B is, this is the question. Okay. So first of all, let us understand the question. Let us understand the question. So one solution, one container is containing water, NaOH. Another container is containing what? H2SO4. Right? This is it. So this volume is equal to 100 liters and this volume is also equal to 100 liters. Okay. So mass, how much is dissolved in this 100 liter? Mass of NaOH, mass is equal to 4 grams. Here mass is equal to, okay, 9.8 grams. So let us find the concentration first of all. Let us find the concentration. And first let us go with molarity. Molarity is equal to number of moles by volume in liters. This we know. So molarity is equal to number of moles means weight by molecular weight. So 4 grams by, what is the gram molecular weight of NaOH? 40 grams. What is that? 40 grams. By volume taken is 100 liters. So here molarity is equal to 9.8 grams by, what is the molecular weight of H2SO4? 98. Gram molecular weight is 98 grams by, again here also 100 liters. Right? So molarity, what do you get? 4 by 40, 10 power minus 1 by 10 power 2, that is equal to 10 power minus 3 molar. Here molarity of H2SO4 is equal to, again 9.8 by 98 gives you 10 power minus 1 by 10 power 2, that is equal to 10 power minus 3 molar. Okay. Let us convert it into normality because n factor is changing. H2SO4 n factor is 2. So here normality is equal to molarity into n factor. So molarity NaOH, what is n factor? So n factor for NaOH is equal to 1. N factor for H2SO4 is equal to 2. Okay. So now molarity is how much? 10 power minus 3 into n factor 1, that is equal to 10 power minus 3 normal. Here normality is equal to molarity into n factor, which is equal to molarity given 10 power minus 3 n factor 2, that is equal to 2 into 10 power minus 3 normal. Right? So whose normality it is? H2SO4, and whose normality it is? NaOH. NaOH. So this is the situation. Initially, their concentrations we have calculated. Now the remaining part is the pH of the resultant solution obtained by mixing 40 liter of solution A. A is what? NaOH. What is B? H2SO4. And 10 liter of solution B. So let us see that. Now, how much taken? What is this? This is NaOH. Again, volume is equal to 40 liters. Normality is equal to 10 power minus 3 normal. Now, what is this? This is H2SO4. Volume is equal to 10 liters. Normality is equal to 2 into 10 power minus 3 normal. Now what he is doing? He is mixing these two. What he is doing? He is mixing these two. So this is base. What is this? This is base. And what is this? This is acid. When they are mixed, a reaction happens between acid and base. Reaction happens between acid and base. Okay. And we know that one equivalent of acid always react with one equivalent of a base. Now what is the reaction here? Acid-base reaction. They react. If the number of equivalents of NaOH is equal to number of equivalents of H2SO4, they get cancelled. And the solution will be neutral. But if any one of it is in excess meaning that number of equivalents are more. So let us see here number of equivalents formula. We have studied number of equivalents is equal to normality into volume in liters. Here also number of equivalents is equal to normality into volume in liters. Okay. So how much normality? 10 power minus 3 into 40. So what you can write? 4 into 10 power minus 2. 4 into 10 power minus 2. We can write it as 0.04. Here number of equivalents is equal to 10 power 2 into, what is that? 2 into 10 power minus 3 into volume 10 liters. 10 liters. 2 tens, 20 into 10 power minus 3. I can write 2 into 10 power minus 2. So which can be written as 0.02. Okay. So here I can write NBVB is equal to 0.04. Here I can write it as NAVA is equal to 0.02. 0.02. So what condition you are finding here? What condition we are finding? We are finding the condition that NBVB is greater than NAVA. So base number of equivalents are greater than acid number of equivalents. Base number of equivalents are greater than acid number of equivalents. Okay. Then we have studied a formula that when base number of equivalents are greater than acid number of equivalents, we have studied that OH minus ion concentration is equal to NBVB minus, when you are mixing this, NaVa by Va plus Vb. This is the formula. We have derived it, how we got it. So NBVB is 0.04 minus NaVa is 0.02 by volume 40 liters of base and 10 liters of acid are added, so it becomes 50 liters. Here this is normality into liter. Liter get cancelled. Then what you get? OH minus ion concentration, you are getting it as how much? OH minus ion concentration is equal to 0.02 by 50. So I can write it as 2 into 10 power minus 2 by 50. So that is equal to 200 into 10 power minus 4 by 50. Okay. So 50 force. So then OH minus ion concentration is equal to, right? OH minus ion concentration is equal to 4 into 10 power minus 4 N. Then POH will be equal to minus log 4 into 10 power minus 4. So this can be written as 4 minus log 4. So 4 minus log 2 square I can write. So 4 minus 2 log 2. So that is equal to 4 minus 2 log 2 is equal to 2 into 0.3. So 4 minus 0.6, that is equal to 3.4. So what did we get? TOH. TOH we got it as 3.4, and we know that pH plus POH is equal to 14. This is at 25 degrees centigrade. When temperature is not mentioned, we have to take this. Then pH is equal to 14 minus POH, then that is equal to 14 minus 3.1, 3.4, that is equal to, what do you get? 10.6. So the answer is pH is equal to 10.60. Understood? So from this, what did you understand? We understood that physical chemistry questions need lot of practice. There is more mathematical operation involved in this physical chemistry questions. We should be perfect with the concept. We should be able to understand the question. We should be able to apply the formula. We should be able to operate mathematical operations in this, and the calculation part is to be correct. So until you find until you solve, until you put all the steps, we don't get to the final answer. So we should be patiently solving until the answer is obtained by using several steps. So physical chemistry needs lot of attention, needs lot of practice. More the practice you do, more easily you can solve the question. Right? In this session, we are winding up this session. In the next session, we shall continue solving problems on pH. More the questions we solve, more the ability you will develop to solve the questions. Right? Thanks for watching. Let's meet in another session.